This video demonstrates the process of using a free online tool to create a spreadsheet from a PDF to use with the Part Builder generic CSV pen type. First, we download the PDF we want to convert. In this simple test case, we are using the ADS8924B.pdf from TI. Now we convert the PDF to Excel using the free online tool at https:/online2.pdf.com/pdf to Excel. Looking closely at the PDF file, we can see that the pinout table is on page 3 and 4, so we could tell the tool to just convert those two pages. So now what we're going to do is drag the PDF onto this, into the tool, onto the Select Files button. And then the next thing we do is we're going to use that scissors icon up to the right there. And there we're going to enter the page range that we want. So this will automatically limit the number of pages. So we're going to set it to 3 or 4. Then we're going to find the Convert button. And the conversion can sometimes take a little while. I'm speeding this video up to get through it. But it took about 1.5 minutes here to get this. So once it finishes, it converts it to Excel and is actually going to download the Excel file and open Excel for us. And then we're going to take a look at the file next. So we can go in the Downloads folder and we can find that and we can open it in Excel again. And the first thing I'm going to do is save it in a part directory where I'm going to build it with Part Builder. So I'm going to save a copy of this in there. And then I'm going to rename the tab to Original, and then I'm going to make a copy of it so that I have the original around all the time. And then I'm going to rename this tab ADS8924B_pinout. And then what we're going to do is start working on the rest of the design. So we're going to take a look at the thing. We're going to auto fit the columns here. Now we can kind of see what's going on, and we're going to compare this to the PDF so we can see the pin table that we wanted, because at first it didn't look like much. But what we can see is at the top it converted that drawing to a table, but we don't really want that, so we're going to go delete that. And again, we're working off the copy of the original, so we don't really care. We're going to come down and delete it till we get to the start of the table. So we're going to select all that, we'll right click, and we'll delete those rows, and then we're going to go down and we'll delete the intermediate stuff, and we're going to combine it all into one table. So we're going to get rid of these ADS graphics, and we're going to get rid of the table header. And then the next thing we'll do is reformat this a little bit. Onto the table format. We can see there's a strange cell merge for the first couple of columns A, B, and C. So we're going to select columns A, B, and C, and we'll use the Merge and Center button to unmerge them. And then we'll select columns B and C, and we'll delete them since they're empty. And this will make the CSV file more logical for us. Then we're going to rename the thermal pad pin to ground, because that's the signal it really gets to. And then we're going to change the pin number for that from empty to tab. In another video, I'm going to show how to get a special Excel macros that come with the CAD Enhanced tools installed in your Excel spreadsheet so that you can save the tab as a CSV in one swift operation using the 1010 button like shown, which avoids all the hassles of doing it properly with Excel. And here I'm going to press the 1010 button. We'll get a menu that says where do you want to save it, and it saves it in the local directory with the tab name ADS8924pinout.csv. So now with Part Builder, we're going to choose a new part from the setup prompt. We're going to go find a directory to work in. So we're going to go to ADS. We're going to create a directory called ADS824B. We'll double click into that and save it, and that'll create the thing. Then we give it a part name, ADS824B, and then we hit the Create New button, and that prompts us to save the SimGen control file in that directory, and then we say Done. So now we have to go find that CSV file that we created. So we're going to go find it. And when we get it, since we're getting it from a remote directory, it's going to ask if we want to make a local copy, and we say yes. And now we're going to change the type to a generic CSV file. And then we're going to open the More Part Config settings, and we're going to configure the generic CSV header. So we're going to look at the file, the CSV file in a text editor. We're going to see the first column is pin name, the second column is pin num. So we do pin underscore name colon in the generic CSV def, pin num colon pin underscore type colon, and then we put an ignore to ignore the rest of the thing. Then we're looking for the header ID, and that's going to be row 2, which is where the last header exists. So then we read it, and it says it found 25 pins, and we're happy with that. So then we're going to go explore the pins and look around. And what we're going to see is that the pin types are not standard pin types for any tool. So what we're going to do is change them. So we're going to use this Pin Explorer GUI, and we're going to go change, and we're going to click select. We're going to find all the power supplies, and we'll change them to power. Assign pin type power. Then we're going to find the grounds and assign the pin type ground. And we're not even using pattern recognition here. We're just doing it individually because there's so few pins, but we could do it with the pattern if we wanted. So now we're going to find all the inputs and assign them to inputs. And by assigning the pins, it gives SmartFrac the ability to place the pins on the left-hand side automatically for us when it runs. So we want to do that. We're finding all the inputs, and we're going to right-click now. Then we're going to assign pin type input. The analog input output we're going to turn into an in-out. And then we're going to look at the digital outputs, and we're going to turn those into outputs. And then what we're going to do is we're going to save those type assignments, and they get saved to that pin type override.txt file up top. And then if we clear it and then reread it, we can see that they clear and then they get assigned. So that's what happens when we run from the start. So now we have good pin assignments, and now what we're going to do is we're going to clean up a little of the names. So the SDO has a dash number, so we're going to go to the SIG rename rules, and we're going to get rid of the dash. And then we're going to read the pin report, and we'll look at the Pin Explorer one more time, and we'll notice that the SDO pins get renamed. So we have to refresh, and then if you look down there, SDO-0 got renamed SDO0. So now SmartFrac can find that as a bus, which is helpful too. And then we're going to look at the reset pin and the CS pin. So the CS we're going to rename CS_N to show it's active low, and reset we're going to show as reset_N, which is active low. So we'll put that in the rename rules, and we'll read the pin report, and we'll say yes, and then we'll go refresh one more time. And now we can see that the column with the original name is now shows the CSN was CS. And now we're going to save our settings. Okay, we're going to clear all the other tools. We're just going to build this for Allegro HDL for now, just to keep the noise to a minimum. And now we're going to open the SDL editor, and we're going to start looking around. First thing we do with the SDL editor is we change the SDL from template.stl file name. So we're going to save it as symbolorder.stl. Otherwise, every time we run, it's going to want to write over that file. So what we're doing is moving to a new file. So now we're looking around in here, and we're going to start moving some pins around in the SDL editor. So our job in the SDL editor is to get rid of all the choose sides and to organize the pins the way we want them to live. So what we're doing is we're finding the CS pins. We move the AN up, the AN diff pair up. We paste in the CSN pins. So we're going to organize the digital pins and the analog pins separately. So up at the top we have, and then the other thing we're going to do is we're going to assign the ref out onto the right. And then it was broken into two symbols, a power symbol, but this is such a small part that we're just going to combine that. So we're going to take the power pins and move them to the top left. And the decut pins, which are power pin, the output power pins, they'll be on the top right. So we cut them, we paste them up here. We're going to put a balance symbol size to separate the power pins from the digital pins, and then we'll increase the balance sim size to 2 spaces. We're going to put the RVDD on the left, the DVDD on the left, and we'll put the decut on the right. And then we'll put 2 spacers between RVDD and DVDD so we can have room for decoupling caps. And then we're going to come down the bottom, we'll put the no connect on the left, and we'll put the ground pins on the right, and then we'll put a balance symbol size between them. We'll save that, and now we'll generate the symbols. And we'll go view the symbol, and there we go. Take a look around. So one thing we could do is really move the analog signals up by the power signals very easily. So we're just going to go do that. We're going to select the analog input and the ref buffs, and we're going to cut them. We're going to go up above by where the power is, and we'll paste them in there. And then we'll have to redo some of the balance symbol size just to respace things right. So we're going to add a balance symbol size after the buffer, and then because I didn't cut that, I'm going to properly, we're going to save it, rerun it, and build it. And now we're going to view the symbols again. And now we can see the analog signals up top. We have the analog diff pair, we got the reference pins, we got the SDI, and then chip selects. And then what we really want to do is save our work, but we're done. We created a part from a generic CSV file.